5.6, composition of functions. We just got through doing function operations, so taking one function and adding them to another, or subtracting them, or multiplying them, or dividing them. You do have to be aware of domains in this sense, because there are situations where x can't be certain numbers, like underneath a radical sign. If it's an even radical, you can't do a negative number in there. That'd be a no-no. When an x is in the denominator, whatever makes that whole denominator into a 0, that is also a no-no. So those are things you have to watch out for. But there's another thing you can do with functions, which is called a composition of functions. And this is a function inside of another function. So wherever the x's were in the first function, all of those x's become a whole nother expression. That is the other function. So as we see here, and the way that it's said is a very interesting way, but we'll look at it here. The composition of a function g with a function f is h of x is equal to g of f of x. Okay, and it's this like a like one of those Russian nesting dolls, or like, an Inception, dream within a dream thing. F of x is being stuck into g of x everywhere the x is in g of x. And then on this whole thing, they are saying, now you give it a new name and call it h of x. Okay, so you plug something into f of x, you get an output. That output goes into g of x, you figure that, and you get another output. That one's now h of x. Let's look at an example. So we got let f of x equal x plus 2 and let g of x equal x squared plus 3. There aren't any domain limitations here. X can be any number when it's just plain x. X can be any number when it's x squared. It'll always end up turning positive anyway. So let's look at f of g of x. Okay, f of x is this one. So when I do f of g of x, I'm going to write down f of x, but everywhere there was an x, I'm going to leave a parenthesis space, and I actually need more space than that. And g of x is this one. And it's going to go in to f of x where the x in f of x was. So back up here, I said, okay, we're going to plug it in that spot, and we're going to stick it, and we're going to put it in there. And then we simplify. Outside the parentheses of 1, so 1 times each is x squared plus 3. And then there was a plus 2 out there. 3 plus 2 are like terms, so x squared plus 5. Okay, now that goes differently whenever we go with g of f of x. We're going to plug f into g this time. So here, okay, what I like to do is put a parenthesis really close to the x. Nothing separating the x and the parentheses. The squared is out. Anything numbers in front, just where the x is. So I've got some number squared plus 3. And that number is f of x. I'm going to plug in x plus 2. And then I'm going to solve this. X plus 2 squared means x plus 2 times x plus 2, and then plus 3. X times x is x squared. 2x, 2 more x, 4, and 3. These are like terms. Those are like terms. So x squared plus 4x plus 7 is your g of f of x. You might see this as g o f, where this is not like an O, it's like a circle, like a degree circle. Or over here, it might have been f of g of x. And then you have this, right? I like to call them the fog and the goth, the f of g of x and the g of f of s. So the little O ends up being like the of part of what you say. Two different ways to see it, be able to recognize it in each. So here's a couple. Give them a try. You're going to find each composition. You can do f of g of x and g of f of x. Give it a pause, give it a try, come back, see what happens. Okay, here we go. And color coordinated here. My x goes here. My x goes there. So when I do f of g of x, I'm going to do 2 times something plus 7. And I'm plugging in 3x plus 5. And then I'm going to simplify. 2 times 3x is 6x. 2 times 5 is 10 plus 7. 6x plus 17. All right, 3 times something plus 5. I'm going to plug in 2x plus 7. 3 times 2x is 6x. 3 times 7 is 21. And the plus 5 is already there. 21 plus 5 makes 26, so 6x plus 26. And you can see that when we do them in different orders, we do get different results. Okay. Evaluating compositions of functions. You can do this a couple of ways. You can take the equations, plug one into the other, simplify, and then put the number in. Or you can take what they want you to do and replace it. If we look at f of g of 3, right, it used to be f of g of x. And so what they want you to do is take g and plug it into f, and then anywhere there was an x in the g, you're going to plug a 3. Same thing with g of f of -1. They've replaced the x with a -1. So you can take the number, plug it into the inner equation first. So, for instance, on, let's do a here. On a, we're going to plug it into g first. So we've got, this one's, well, let's do it color coordinated again so we can see what's going on. Still don't know what I'm doing. The x here and the g there. Okay, so first we're going to plug it into the g, so we're going to do 3 squared. Let's do that. Well, redo, but eraser. Go blue. 3's in blue. Okay, so we're going to plug the 3 in there. So then we get 9 plus 2, which is 11. Now the 11 is what we're going to take and we're going to plug into 3 times something minus 4. Plug the 11 in there. Well, I guess I should do that in green to make it color coordinated better, because that's where the 11 came from. And then we're going to say 33 minus 4, which is 29 overall. The other thing you could have done was taken f of x, plugged in g of x, and then simplified 3x squared plus 2 minus 4, 3x squared minus 2. And then you plug in the number that you need to. So 3 times 3 squared minus 2. And 3 squared is 9, so 3 times 9 minus 2. 3 times 9 is 27, minus 2 is 25. That went weird. Oh, there we go. I figured out why. 3 times 2 is 6. There's our problem. 6 minus 4 is positive 2, plus 2, plus 2, plus 2 makes 29. That's how we get the same one. Make sure you distribute properly. Okay, so that's the first one. Let's look at what happens when we do g of f. Either way is okay to do. If you're simplifying, you'll have to plug one into the other, but when you're solving in this manner, you can. And let's see, if we color coordinate, there's my x, there's the x in g, and then this is the number I'm plugging in. Okay, so we're going into f first, so 3 times something minus 4, and we're going to plug in a-- and that's -3 minus 4, which is -7. Now we're going to do something squared plus 2, and we're plugging in the -7 that we just figured. Okay, so plug it into the F one first, get your output, that becomes your new input, plug that in to G, and you're going to finish solving. -7 squared is 49. 49 plus 2 is 51. You could also simplify it down to figure out what the equation G of f of x looks like, and then you can plug the -1 in there. We can also evaluate composition of functions using a graph. You're going to do it in the same kind of way. You're going to work these inside out. The innermost one you do first. You put that input in, you figure out what the output is. You put in that x, you're going to figure out that y. That new y becomes your second x, and you're going to plug that into the outside equation and get another second y output. That's your final answer. So let's look at A. Okay, we're going to use the graphs. One's got f of x on it, one's got g of x on it. So let's see. We'll do f, we can color coordinate it, we've been doing green. G, those are your different graphs. So when we're plugging it into each one, we got to go to the right graph. So first, we're going to plug it into the G. So we're going to come over to the 3, right here. So x is 3, we're going to go up, and we figure out that y is 2. That is what we're going to take and plug into the then f equation. And when we plug in 2 into f, we get 2 out of f. So A is 2. If we look at B, we're going inside. We're going f first. So I'm going to erase what I did there, my tracing of my inputs and outputs. This time I'm going to go input into f is 4 first, which outputs at 0. And so then I'm going to come down here and I'm going to input 0, and it outputs at 0. So 0. And that's how you use a graph to do it. Work the inside piece, plug that in for x first, get the y. That becomes your new x on the other graph. Plug that in and solve. Okay, that's how those work. We can do the same thing using a table. Okay, we got an f of x table, we got a g of x table. Start on the outside, work your way in. The first one starts with g is 16. So if we go where g is 16, we plug in the x here, we output 8. So we're going to take that and plug in 8 here, we output 12. So A, f of g of 16 equals 12. B, erase my path here. Start fresh and clean. B, we're going to start with f is 8. So we go here. Our output is 12. So we're going to take that and plug it into the next equation for x. The output is 6. So g of f of 8 equals 6. That's what we're looking for. Okay. Here's a few for you to try. Give it a pause. The top one, they give you the equations, you run them. The next one uses the graphs. The next one uses the tables. Good luck. Pause, try, come back, see how it goes. All right, let's look at number 3. Okay, so here's F, there's G, and we're going to do that number first. So F of G. Okay, you could even draw it out in this fashion. So I'm going to do 4 times something plus 7. And then I'm going to plug in 3 times something plus 5. And what I'm going to plug in is 0. And then 3 times 0 is 0. 0 plus 5 is 5. 4 times 5 is 20. 20 plus 7 equals 27. And we also have to do B, right? That was A. We got to do B. So I'm going to do B. B is going to be in green for G of F. Okay. Outside is the G. So 3 times something plus 5. Inside is the F. 4 times something plus 7. And what I'm plugging in there is the 5. 4 times 5 is 20, plus 7 is 27. 27 times 3, 60 and 21 is 81. 81 plus 5 is 86. Let's see. All right, I think let's try 4, a little separator. 4. F of G, there's G of F of 2 and F of G of 1. So G of F of 2 equals, and F of G of 1 equals. So we're going to start with F is 2. Take that up, figure out the output. We output at 2. That's our new input. We input at 2. We output at 4. So that one equals 4. Just follow the path. You don't actually have to write on it, but I'm doing it to be able to show you how my brain's moving through it. The next one, we're going to start on the G graph at 1. Follow that up to where it hits, comes out at 2. That's what we're going to plug input. Comes out at 2. So we've got our answers there. And then let's see number 5. Number 5, we're supposed to do F of G of 8 and G of F of 0. So the first one, the inside is a G. So I'm going to start at G is 8. And we're on the tables this time, so the G graphs start at 8, outputs at 4. 4 is my new input, outputs at 8. So that would be 8. Then we're going to do G of F of 0. F of 0 comes out as 4. We're going to input 4, comes out as 2. Find the 2. And that's what it takes. Now, let f of x equal x to the negative 1 and g of x equal 2x minus 4. Find each composition and state the domain. Now, what we have to be careful of is what that means. So let's redefine f of x. Okay? F of x is actually 1 over x, because that's going to drop. I'm just going to turn the thing. Now this has a problem. X cannot be equal to 0. So when we plug that in, x can't be 0 when we're using f of x. Whatever would make that bottom 0. So initially, for f, 0 is not an option. But let's see how it plays out whenever we start plugging these into each other. Okay, there's my G, and there's F. So we got 1 over something, and what we're plugging in is 2x minus 4. So really, we can't have this bottom equal 0. So what would make 2x minus 4 equals 0? When we add 4, 2x equals 4, divide by 2, x equals 2. In this instance, x cannot equal 2. This is my composition. It's as simple as possible, and x can't equal 2 because it would make a 0 in the bottom, and that's undefined, and that's no good. Okay. Now, when we do g of f of x, we're doing 2 times something minus 4, and that something is 1 over x. Here, it's 0. We're going to distribute this in, so it becomes 2 over x minus 4, and x cannot be equal to 0 this time. That's a no-no. 2 times 1 over x is not 2x. The 2 is times the 1. Remember, this is over, straight across. Okay? Liquid leaks from a container to form a circular puddle on the floor. The radius r in inches of the puddle after t minutes is given by the function. So r is radius and t is time. The area, big A, in square inches of the puddle is given by the function area a of r, or area according to the radius, is equal to pi r squared. So they used a of r because area is in terms of r. You use the radius to find area of a circle. Use a composition of functions r and a to write a function that represents the area of the puddle after t minutes. Okay, so on part A, we want something that's a of t, and that is equal to a of r of t. And so we're going to take a, and it's pi times something squared, and r is equal to 2t, right? So we're going to plug in the 2t here, and we're going to simplify. A of t equals pi. This 2 goes on the 2 and the t in this instance. It's not a binomial, it's a monomial. So everybody gets an exponent of 2. 2 squared is 4. T squared is t squared, so 4 pi t squared. That would be our function, where area is in terms of time. What is the area of the puddle after 10 minutes? Well, this is time, so we're going to plug it in. So part B is a of 10 equals 4 pi times 10 squared, because we're plugging in 10 where t was. And then we're going to do the math, and we're going to say, well, a of 10 is approximately, it didn't say where to round, so we'll just do 2. So 4 times pi times 10 squared. Should be outside. Double whammy there over 2. 1,256.6, 2 decimal places, 4 inches. Square inches. Okay, inches squared. That's what area is in. Area is always in squared things. Should put the E on there. Okay, so 1,256.64 square inches. If you want to convert it to feet, have a good time. All right, here's some practice problems for you. Give you a good chance to see what's going on. Try them, and then come back and see the answers. All right, let's look at number 6. F of g of x. Find the composition, state the domain. There's my x. And so that's all of g that I'm going to plug in there. F of x is one that I need to fix. F of x, more properly related, is 3 over x. So x can't be 0 if you have just plain. Now on 6, we're supposed to take f, which is 3 over something, and we're going to plug in g, 2x minus 2. There's nothing to really simplify there, so I just need to figure out what x cannot be. Well, 2x plus 2 equals 0. Sorry, minus 2. We're going to add 2 to both sides. 2x equals 2. Divide by 2. X can't be 1. If x was a 1, we'd have a 0 on the bottom, and that's a problem. Okay, so that's number 6. Let's try 7. 7, we're going to take g, which is 2 times something minus 2. We're going to plug in f, which is 3 over x. 2 times 3 is 6 over x minus, that's not the right number, 2. There's nothing to mix there. We just have to state the domain that x can't be 0 because you can't have a 0 in the bottom. And then let's look at number 8. A salesperson earns 5% commission on daily sales over $1,000. The function f of x equals 0.05x models 5% of an amount x. The function g of x equals x minus 1,000 models how much greater an amount x is than 1,000. Use a composition of the functions f and g to write a function that models the commission earned on daily sales of x dollars. What is the commission earned on daily sales of $5,000? Okay. So a salesperson earns 5% commission on daily sales over 1,000. We need to figure out how much is over 1,000 first, then we get to do the 5%. So the 5%ing is last. So we want f of g of x. So, nope. Yep, that's what we want, because we want g first, because g is the one that figures out how much over 1,000 we are. So, this one goes inside of that one. So f is 0.05 times something, and we're going to plug in x minus 1,000. Okay. And we actually even have an x, so if I wanted to, I could say, all right, we're plugging in 5,000 into here, and we're going to run that number down. 5,000 minus 1,000 is 4,000. And then we're going to take that, 0.05 times 4, 1, 2, 3. So $200 in commission. You make an extra $200. Congratulations. And that's composition of functions. Plug one into the other. Be careful.